Hello everyone. So the question is two identical parallel plates, capacitor of capacitance C each, have plates of area A, separated by a distance d. The space between the plate of two capacitors is filled with three dielectric of equal thickness and dielectric constant K1, K2 and K3. The first capacitor is filled as shown in figure 1. This is figure 1. And the second one is filled. This is as shown in figure. This is figure number 2. If these two modified capacitors are charged by same potential V, the ratio of the energy stored in two would be E1 referred to capacitor 1, E2 to capacitor 2. So in this question they have given us two identical parallel plate capacitor and of capacitance C having area A, and they are separated by a distance D, and the space filled between the plates of two capacitor by three dielectrics which are K1, K2 and K3. So they said that they are having same potential V, and we have to find the ratio of energy stored, means even by E2, and even is preferred as the energy related to capacitor first, and E2 is related to capacitor 2. So this is the first figure. So if we simplify these 2 figures, then this can be like this, means K1, K2, K3 in the first are connected in series, and in the second they are connected in parallel. So first we will find out the value of capacitor C1 and C2. As it is clear that C1 is series, so now we'll proceed with the solution. If we consider this figure 1, which means that K1, K2 are in series, so 1 upon C1 will be equal to 1 upon K1 epsilon naught A D by 3. As they given in the question that these are filled with, these are having a distance d, it means distance is d. So if we consider this distance, then this will be equal to 1 by 3, equal to 1 by 3, equal to 1 by 3, as the distance d is divided into 3 parts. So for K1 it will be d by 3, K2 it will be d by 3, and for K3 it will be d by 3. So this is K1. Considering K1, distance will be, separation distance will be d by 3. Now for K2, epsilon naught A d by 3. For K3, 1 plus K3 epsilon naught A by d by 3. So if we take common d, 3 epsilon naught A, so this will be equal to 1 upon C1 d 3 epsilon naught A 1 plus K1 1 plus K2 1 plus K3. So C1 is equal to 3 epsilon naught A by D, and this will be equal to K1, K2, K3, K1 plus K2, K1 into K2. K1 K2 plus K2 K3 plus K3 K1. So this is the value of capacitor C1. Now we will calculate the value of C2, as second figure is related to C2 and we know that these are connected in parallel. So the value of capacitor C2 will be equal to K1 F E epsilon naught A by D by 3 plus K2 epsilon naught A by D by 3 plus if we consider the second case as shown in this figure. In this figure, separation distance is same, but area is divided into 3 parts. So area of K1 will be A by 3 as whole area is A, and for K2 it will be epsilon naught A by 3D, and for K3 it will be K3 epsilon naught A3 as area is divided into 3 parts. So this will be equal to epsilon naught A, and 3D can be taken out as common. Then this will be equal to K1 plus K2 plus K3. So we have calculated the value of C1 and C2, and now we have to calculate the value of E1 and E2. So E1 by E2 is equal to half C1 V square by half C2V square, as E is equal to half CV square, and it is given in the question that the potential is same for both. So half and half will get cancelled out and V square will get cancelled out. So it will be C1 by C2. Now we'll put the value of C1 and C2. Value of C1 is 3 epsilon naught A D K1 K2 K3 by K1 K2 plus K2 K3 plus K3 K1 divided by C2 epsilon naught A by 3D K1 plus K2 plus K3. Now the value of E1 by E2 will be equal to 9 K1 K2 K3 by K1 plus K2 plus K3 into K1 K2 plus K2 K3 plus K3 K1. So this is the ratio of E1 by E2, and this is our answer. Thank you.
Hello everyone. A simple pendulum of length L is placed within the plate of parallel plate capacitor having electric field E as shown in the figure. Its bob has a mass M, charge Q. The time period of the pendulum is given by. So if you see, if I want to calculate the time period, it will be under root L by G effective. So let's calculate the G effective here. Right. So here it will be moving here with acceleration. The acceleration of this, it will be, if you see the force, electric force, it is Q into E, right? So the acceleration will be force by mass, that is this. Now if you see, if you add the G effective and if you calculate the G effective here, so I will write G effective, if you know already, it is G vector minus acceleration vector. So acceleration of this, if you see here, the acceleration of frame is in this direction. So you will add the acceleration in opposite direction. So I will write this, it is G this. So I will write G effective is equals to under root of this. So we got this G effective and I will write it is equals to under root of plus kq by m whole square to the power half. Now if you see the option, so yes, A is the correct one. Thank you.
Hello. The question is, figure shows the charge Q, that is charge versus V, that is voltage graph for series and parallel combination given to capacitance. The capacitances are. So we know how capacitance can be written. We know the relation between Q and V. Q is given by CV. Fine. We have to find the C. C can be written as Q divided by V. Fine. It means slope of QV graph, slope of QV graph will give C. Fine. Now for A, how can we find slope? We have given point 500, this is 10. Slope will be 500 divided by 10, that is 50. Now if we take for B, it is 80 divided by 10, that is it. It means our options will be 50. This is what our capacitance. 50 and it means option C is correct. I hope you have got your answer.